Hello, everybody, and welcome back to the Space Chams podcast. I am your fantastic, wonderful host, and today we have some very special guests. And I was shocked to see two, not one, but two wonderful people from the DaVinci Plus program, and I am super excited to sit down with Giada Arney and Stephanie Getty today, both of which are deputy principal investigators to the DaVinci Plus program, or mission, I'll say, program, mission, either one. Not sure. They'll straighten it out and they'll tell me everything I don't know. So that's the beauty of it. But we're super excited to talk to each of them today. They're going to tell us a little bit about themselves. Hopefully, I won't embarrass them with any terrible questions, and I won't embarrass myself. So that's the beauty of it. But we are going to get down to it. How are we doing today, everybody?
Great. Thanks for having us, Jim.
Yeah, sounds like a fun podcast.
I hope it's fun. But thank you guys for coming today. I'm super excited. And I've been a little bit more interested, especially this year, in Venus itself. I was kind of I've always been a moons man. I love Titan and I love Europa. And obviously Mars is always in the news. But this year, Venus got a little more love for a little bit. I forget exactly why, but they found an element or a chemical in the atmosphere that they thought would link it maybe to, life way back when, things that you'd only find where life is. And so I know it got a little more sunshine. And so it's very exciting to see that NASA is coming up with not one, but two missions to focus on Venus. And so it's super exciting. We are going to start out today with some beautiful introductions. Anyone want to go first? Giada, Stephanie, either one, whoever wants to give a solid introduction of themselves.
Okay, well, I can go first. So I'm Giada Arney. I'm one of the deputy PIs of the DaVinci mission. We've renamed it to DaVinci rather than DaVinci Plus. So DaVinci is a really exciting mission to be serving as deputy PI on, since it's going to be the first NASA probe mission into the Venus atmosphere in decades. My background is, so I wear a lot of different hats. I have a background in planetary science and astrobiology. So astrobiology is the search for life beyond the Earth. So I think a lot about how we might be confident if we think we've detected life beyond our planet. I've done work thinking about how we might detect and disambiguate potential signs of life that we might see in the future on exoplanets, which are planets beyond our solar system. I've also done observations of Venus with ground-based telescopes on Earth, trying to understand and characterize Venus's lower atmosphere to get a better understanding of what's the composition of that very deep, inaccessible layer of the atmosphere. What's really exciting about DaVinci is we're actually going to go there to that deep atmosphere and make direct measurements in situ, which is really, really exciting. So excited about that. I'm trying to think of other things that I should say to introduce myself. Is there anything in particular that you would like me to talk about?
No, not in particular. I mean, how about, a favorite hobby or something, anything you want?
Yeah. So favorite hobby, I love gardening. I've got probably about 50 tomato plants, not exaggerating, growing outside my house. My husband is building a greenhouse for them right now, so I'm super excited to see them when they finally move into that greenhouse when it's finished. They're my babies. I like to baby them along every step of the way.
Now, every time I see that's amazing, because every time I think of someone at NASA, anybody, and then I think of, a little bit of gardening action, it always brings me back to Mark Watney, the Martian, and it always gets me there. So maybe, Giada Arney, she'd be the Venetian. I'm excited. I'm excited about that. So that's great. No, that's awesome. Thank you so much for the introduction. Stephanie, I cannot wait to hear it.
All right. My self-introduction starts with kind of my training. I came out of graduate school as a physicist, focusing on experimentalism if that's a word, looking at novel properties of materials, and then I kind of translated that into an expertise in technology and application of new materials to space as I joined NASA in 2004. And so, over the course of my career at Goddard, I engaged with a lot of different diverse people. That's one of the amazing things about working at NASA Goddard Space Flight Center, is that there is just a wide range of expertise and amazing coworkers. And I finally found my happy place, my home in planetary science in the Solar System Exploration Division. I spent a few years developing new types of instrumentation to make what we call in situ measurements of chemical composition, specifically focusing on organic diversity in planetary environments and how that can tell us about habitability of planets and potential biosignatures that may be present in some of the habitable environments in our solar system. Through that experience, I kind of developed a perspective through the eyes of a rover because I'm on the science team for the ExoMars rover, and specifically the Mars Organic Molecule Analyzer, which is going to launch next summer. We're so excited, and go drill deep into the surface of Mars and look for biosignatures further into the surface than anybody's looked before. And so that's very exciting. I'm thrilled now to be taking some of that expertise in planetary mass spectrometry and applying it to helping to lead the DAVINCI mission. I'm also bringing my expertise in kind of science management. I'm also the deputy director of the Solar System Exploration Division at the current time. And so I get to work with just a fabulous group of really dedicated, brilliant planetary scientists covering everything from return sample analyses to magnetospheric studies to modeling of exoplanets and beyond. So just really privileged to work with the group I do, and really privileged to be part of the DAVINCI mission as a deputy PI.
Wow, it's super exciting. Wow, that's amazing. I love one of my favorite parts about Space Jams. I don't know about everybody else, but I love hearing about how people got to where they are. And there's so many different journeys on how to get there. The physicists and everything, and the management. And there's so many different skills involved. And I think of NASA people, whether they're astronauts or whether they're deputies of some kind, they are Swiss Army knives. They can do a lot of different things, and we'll call them NASA Army knives because NASA and everything else. But my gosh, it's incredible. Two amazing people here today. If I were to introduce myself, it would be embarrassing in front of you. I am a graduate, and I host a podcast. So that's wonderful. It's okay to laugh. Laughter is good. But all right, so let's get into the nitty gritty. We have Venus, and now the DAVINCI, just the DAVINCI mission. Very exciting. So from what I know, and hopefully at this point what some of my viewers know, is that Venus is not very hospitable. It's a bit warm there. It's actually our warmest planet in our solar system. And so the interesting thing about the DAVINCI mission is we're going there to see if it used to be habitable, and we're looking for different kinds of signs of what we believe takes to support life. So we're looking for, with like a remnants of an older climate, a more Earth-like climate, and we're also looking for oceans. And I believe, I'm not sure if this is the DAVINCI or the Veritas mission, but we're looking for if Venus has signs of tectonic plates and things. Is that all correct?
That's right. Yeah, we're going to be taking a probe by a carrier spacecraft to look both above and below the clouds of Venus at what I like to think of as kind of fingerprints in piecing together Venus's history. These fingerprints can be chemical in the atmosphere. We can look at signatures in the composition of the atmosphere to help us tell the story, the history of what Venus used to look like and what has happened since and when it became such an inhospitable place. And we're going to couple those measurements. We're going to interpret those measurements also with imagery of the surface, and Veritas is going to do this very well. We're not going to speak a lot about Veritas because we're not the experts on that mission. We'll speak more about DaVinci, but Giada can tell you we're going to be looking also at very special parts of the surface, very special features of the surface called tesserae. They're mountainous, they're rugged, they're highlands, so they're higher than most of the surface of Venus. And we think that they hold records of water and interactions between rocks and water back in Venus's past.
Wow. Yeah, that's amazing.
Yeah, and those tesserae are really fascinating because some people have interpreted them as maybe older than the rest of the surrounding basaltic plains that Venus's surface is made out of. So we think most of Venus's surface is made out of volcanic rocks, but these tesserae are really special because there's suggestions based on our observations of them so far that they might be different in composition compared to the surrounding basaltic plains. And maybe, just maybe, they're the remnants of ancient continents that once existed on Venus when Venus may have been more hospitable in the past. Maybe they're composed of rocks that formed from water-rock interactions and plate tectonic processes. So if that's true, Venus might have these clues on the surface in the form of these tesserae that are hidden in plain sight that we need to get more information from them to understand, what exactly are they? They're really, really tantalizing. They're really, really special, we think. But we're going to be descending over one of these tesserae called Alpha Regio when we drop our descent probe into the atmosphere. And on the way down, it's going to be taking photographs of Alpha Regio, which is an example of one of these tesserae. We're going to get up to meter scale images of Alpha Regio with our downward looking camera. And from those images, we're going to learn a lot about the topography of Alpha Regio and also the composition of the rocks that make up Alpha Regio, so we can try to piece together what exactly this mysterious surface is composed of and what its history is.
Yeah, that's amazing. And I love the idea of, descending into and through that, incredible atmosphere. That's pretty similar to, now I am wondering, is it going to be similar to the Huygens probe to Titan, where that video is incredible, and Titan is one of my favorites for many literary and scientific reasons, but I love Titan. But the probe goes through and you see it pass through a thick atmosphere, and then you get this view of mountains, and you're like, wait a minute, for a second, it kind of looks like a planet, kind of looks like somewhere you could go. And then the probe, I believe it crashes. I mean, you don't see a lot after that. There's a small video, but will the DaVinci probe be anything like that?
So in fact, we have team members from the Huygens probe that went through the atmosphere of Titan that are also participating in our atmospheric structure investigation and on our science team. So there is definitely continuity. Our group at Goddard also built the mass spectrometer, the gas chromatograph mass spectrometer that descended on the Huygens probe. And you're right. I mean, descending through the cloud deck at Titan was just breathtaking, and it'll be no less so at Venus. We're so excited for that. The one difference is it turns out that the Huygens probe did survive landing. It fell gently onto the surface. The surface turned out to be squishy, and we don't expect anything quite like that at Venus. But it continued to transmit data for, I believe, another hour at least, and volatilizing compounds from the surface and continue to take data. In contrast, Venus is a very different surface environment, and our probe, DaVinci probe, is not required to survive the landing. If we do, however, we have the capability to continue to measure for, we think, another 17 or 18 minutes. But we're going to make all of our measurements descending through the atmosphere at intervals so that we can tell the structure of the atmosphere compositionally, also in terms of winds and temperatures and pressures. And then we're going to transmit all of that data back to our carrier spacecraft before we hit the surface, just in case we don't quite survive.
That's awesome. I love that. Yes. So I love the connections, and I love how people are, working all over the clock. Now, DaVinci, its main mission is actually to look at the atmosphere and to observe the atmosphere. Is that correct? So it's focused mostly on the atmosphere. I think I read a little bit about the Veritas, and Veritas has a different mission. It's focused on a little bit of something else. But another thing that a lot of people ask all the time, they say, and these are mostly non-space enthusiasts, but they're like, why are we spending all this money to go to another planet, and learn about another planet? Why are we doing all this when we have all these problems here? And both of these missions have been given, I believe, $500 million worth of funding to go to Venus, and I'm all for it. But what would you say to someone who questioned that? Like, why are we going to Venus? Why are we spending all this money? How does it help the common person? How does it help me?
Well, I can give my perspective on why I think Venus is so interesting and compelling as a scientific target. We have so many questions about how Venus evolved through time. There's these hints, as we've been talking about, that Venus may have been habitable in the past. So if that's true, that would mean that our solar system had two habitable worlds side by side together for most of our solar system's history. And I think that would really give us a broader cosmic perspective on our own planet and the relationship of our planet to the rest of the universe, right? Because we've got, two worlds side by side that were habitable, but something on Venus went wrong. So we'd like to understand how habitability evolves through time, how habitability can end, and Venus might be able to teach us about those processes. And those are also important to learn about as we're starting to search for potentially habitable worlds beyond our solar system. We need to understand how habitability evolves, how it's maintained, the processes that are involved with those processes, so that we can know which planets to search for when we're looking for Earth-like worlds beyond our solar system. So I really think by looking to Venus, it's really a touchstone in teaching us about, counterintuitively, in teaching us about Earth, and teaching us about how a planet that may have looked more like Earth in the past changed dramatically over time. So Venus might be able to tell us things about our own planet.
And to follow on that, if I might, Jim, I always find it, really interesting and exciting to know that modeling expertise that was developed to explain why Earth's climate is the way it is are now being applied to Venus. And we're learning a lot about how to model climates of planets in general by being able to compare these two planets. Now, beyond just the human curiosity that drives us beyond Earth and to explore beyond Earth, I mean, we're also able to inspire kids that are now in elementary and middle school to study science. I mean, this is a broader impact than just our one or two missions to two missions to Venus now coming up. It's really about satisfying the human need to learn and to be inspired so that we can push our science and technology and engineering and mathematic innovation and inspire the kids of today to undertake big challenges and answer big questions about where we came from and why we're here on Earth and what comes next for us and the solar system and beyond.
Those are two good answers right there. I like it. I like it. Where were you guys when I was in middle school and I hated math? I needed you guys to help me get inspired so I could go to NASA and do something. That's okay though. I forgive you. Don't worry about it. No, so that's fantastic. That's amazing. And I totally 100% agree. And I always know those answers, but I think they're great answers it's great to get multiple perspectives, because when people do come up to you, and when they come up to me, and when they come up to anybody who likes space, I think that's an important question to have a good answer to. And I always understand, you know, it's like having different perspectives. You can't know everything about Earth just by being here. You need to compare it to something else. And we have two wonderful, what should I call them? Experiments called Mars and Venus that we're checking out, and we're trying to learn a little bit more about ourselves from others. It's wonderful there. There's something there. There's something very human about that, but it's awesome. Now, there is also another thing going on in the atmosphere, I believe, of Venus. There is unknown ultraviolet absorbers, and I know that on board DaVinci there is the Cubis, I believe that's how it's called. I'm going to call it that, but it's the compact ultraviolet to visible imaging spectrometer. And the reason that this is kind of exciting is because there's ultraviolet light being absorbed on Venus, and no one really knows why. It's kind of an unknown thing, and I'm sure that's part of the mission, and I'm sure everyone's excited to figure it out. But why is that important? Why is having ultraviolet be absorbed important?
Well, the unknown UV absorber, it's a really interesting puzzle that's been puzzling the Venus community for quite a long time. And part of the reason why this is such a important question to solve is that the unknown UV absorber is actually responsible for absorbing half of the incident sunlight that hits Venus's atmosphere. So it's a really important contributor to the radiation balance and the radiation budget of the planet's atmosphere. And also, when we're thinking about exoplanets, there may be unknown absorbers in exoplanet atmospheres. So we've got this unknown absorber in this planet next door. We'd really like to characterize it better so that we might stand a chance of better characterizing the puzzles that we're going to face when we start to characterize exoplanets. So that's why it's important, at least in my opinion, to study and understand the composition and character of this unknown absorber. And Cubis, which is that instrument you mentioned, is going to be able to measure the spectrum and the ultraviolet part of the spectrum that will help us to characterize that UV absorber and its distribution. And we're going to try to map the spectrum that we measure of the UV part of Venus's spectrum to different candidate UV absorbers to try to help us understand what are plausible candidates that can explain what we measure.
And I'll just add to that. Yeah, we're excited about Cubis. It's going to push the envelope in terms of spectral range. So we'll be able to look at new features that haven't been observed before. And we're also going to be able to look at an image and tease out the spectra from each of the different pixels on that image. So we'll be able to correlate particular features in the clouds to an individual spectrum. And so that's just a new way of looking at the ultraviolet features at Venus, with detail that we haven't been able to do before. So that's really exciting. I also wanted to kind of mention the importance of understanding Venus holistically, because when we're studying habitability of a planet, past or present, it's really important to look at the system of the planet, to look at the planet from a number of different aspects, and to be able to understand the planet, top to bottom. And the cloud deck and the UV absorber are really important contributors to what the Venus atmosphere, how it works, what it's made out of, how those different pieces of the atmosphere work together to generate clouds and hazes and aerosols and a supercritical fluid near the surface. It's a complex, layered atmosphere. And so being able to take discrete, discovery-driven measurements of atmospheric composition, like DaVinci does, at every level of that atmosphere with higher resolution than we've ever done before, will really help us answer the question of how the Venus atmosphere works. And so, without really knowing those details of the atmosphere, we won't be able to ask the next more sophisticated questions about Venus habitability, about weird chemistry that might be happening there. It's really important to have context when we ask future questions.
Yeah, I couldn't agree more. And I find that I've done a couple of interviews, and there's been a couple of times where spectroscopy, I believe, is the correct word. Yes. And it always comes up. And I think the beautiful thing to me because I am not a scientist, is the idea of spectroscopy is getting a lot of information from very little information. Is for what I see. It's like they use, you use particles to paint a picture almost, and that is a really stellar thing. And it's such a NASA thing too. It's such a great scientist thing to do, to pull, these big answers out of these seemingly small observations, and it's fantastic. And I'm so glad it can be used here as well. And I'm pretty sure that that's being used to help find some exoplanets as well. I mean, I think we've seen over, I think, what's the number right now? It's like 4,000 exoplanets.
4,000, yeah.
Yeah. And we were lucky enough to talk to a exoplanet scientist one time, and they were telling us all about that and how spectroscopy is super important. But that's a super important thing. So if any, people out there, if any young students out there who, we were talking about before, trying to get into spectroscopy, because I don't understand it, and I hope more people can tell me about it in the future. But yeah, that's awesome.
What's so cool about Oh,
no,
sorry, is it okay, Jim? Yeah, I was just going to say, what is so cool about spectroscopy, and Giada is an expert in this, but I just think it's so incredible that you can look at something from very, very far away, collect the photons from this object very distant from Earth, and be able to tell how the molecules are moving. Because the spectroscopy is just like signatures of vibrations in molecules and rotations in molecules. It's like this connection, this cosmic connection between what we can see, with our telescopes and with our instruments, to just the very details of how, submicron scale molecules are moving in space. It's incredible.
Yeah, awesome.
Yeah, I always like to tell people that spectroscopy, even though it seems like this weird, mysterious, opaque thing, it's one of the most useful things that we have in the astronomer's toolkit. It is so fundamentally important to how we do astronomy, because it's how we know what everything in space that we've never visited, what it's made out of, right? How fast it's moving, these really basic questions that we need to be able to answer to understand these distant objects, right? It's how we know what the sun is made out of. It's how we know what Venus is made out of. It's how we know what Jupiter is made out of, what Pluto is made out of, what stars are made out of, and other solar systems, what distant galaxies are made out of, how fast they're moving towards or away from us, how they're rotating, all of these really, really important things. So spectroscopy, I would say, it's not like a side part of astronomy. It's like a fundamental, central part of astronomy and planetary science.
That's awesome. Yeah, I definitely underestimated spectroscopy before I started this, but after talking to so many people, I understand it's super fundamental, and it's super important, and it's super helpful in understanding the composition of things. And a lot of, we were talking about Swiss Army knives and things, but a lot of space science is it's interdisciplinary. You have to understand physics and how physics relates to biology. And when you're looking for, signs of life or signs of habitability on another planet, that connection right there is super important. We're part of this mission, whether it's Veritas or DAVINCI, they are looking at, the remnants of past oceans. And, we love looking for water. That's one of our biggest things as humans. We can't get enough of water. Unless it's raining. That's pretty much, here on Earth, unless it's raining. But when we're looking for water, we're the only planet that has liquid water that we can, find. And I think it's exciting that, we're trying to look for remnants of old oceans. I thought maybe if that's part of the DAVINCI mission, if you guys could talk about why that's important and why looking for remnants of old oceans is important.
Yeah. Why don't I start, and then Giada, you can add to it. Well, I mean, so it can be a very funny joke to talk about how many times NASA has found water on Mars, right? But the truth is that, Mars isn't a monolithic place, and Venus isn't a monolithic place. And so just like Earth has a whole diversity of geology and kind of, environments to it, these planets are, worthy of investigation from many, and from many different vantage points. And so, so understanding the extent of the distribution of water, not only on Mars, but also Venus, and also in the outer solar system. We have ocean worlds that are orbiting Saturn and Jupiter right now. It's very exciting. And water actually is thought to be one of the three main ingredients necessary for life. So, water, an energy source, and a source of nutrition. And so water is a fundamental thing to look for. It's also, it's one of the universal things to look for. Water isn't going to really change, according to the environment. Whereas, what you might consider a nutrient, or what how you consider energy sources, really depends a lot on what environment you're looking at. But the really cool thing about Venus is that back in pioneer Venus days, they discovered this just highly unusual ratio of two atoms, a deuterium atom to a hydrogen atom. And basically deuterium is a slightly heavy version of hydrogen. Okay, it's got an extra neutron. So, so looking at how deuterium compares to hydrogen in water molecules can tell you about how much water was originally on Venus. And if that ratio is high, it means that there used to be a heck of a lot more water on Venus. And that ratio is very high on Venus. So we need to, so our goal is to interpret that finding with the rest of kind of the history of Venus that can have impacts on how we interpret that finding. So we need to know what was the original fingerprint of water on Venus as it was forming, and as it may have been accreting, volatile rich impactors like Earth did. What happened, during kind of the catastrophic periods of volcanism on Venus? When did those occur in Venus's history? And if we put all of these, what we think of as like sources and sinks, like production mechanisms and loss mechanisms together, then we are really, really, equipped to interpret this deuterium to hydrogen ratio in a way that can tell us not only how much water was on Venus, but also the time period over which it was lost. And those are really important open questions now. There are models that are consistent with Venus never having had oceans, and there are newer models consistent with Venus having had oceans for billions of years and only having lost them, a few 100 million years ago, which is like a blink of an eye in geology. So, so that's really, really exciting. And I'll hand it over to Giada if she wants to add.
Sure. Yeah, I think that was a wonderful, complete answer about why these observations of this D to H ratio, deuterium to hydrogen ratio, are so important, and also why habitability is so complicated, right? Like, habitability is extremely complicated, and water is central to our definition of habitability because, as Stephanie told you, it's one of the necessary ingredients for life as we know it. And understanding habitability relies on really understanding a very complex web of planetary processes and phenomena. And so we're trying to tackle this from multiple angles, right? With the D to H ratio, with looking for remnants of, water rock interactions on Venus's surface in these tessera regions, and also just by generally placing those in the context of how Venus may have evolved through time, by trying to get a better understanding of the history of processes that occurred on Venus, volcanic processes, how Venus formed, how Venus got its water, and also how those happened in relation to how Earth evolved and how Mars evolved. We want to try to understand all of this in the context of how it relates to each other. And this is important both for understanding habitability at Venus, but also understanding habitability, as a more general process. What makes Venus, I think, at least to me, so interesting in the context of habitability is that it straddles the boundary of where our models predict habitability might or might not exist. And understanding where that boundary lies between, habitable planets and non-habitable planets is going to become increasingly important in coming years as we're searching for planets inside that boundary that we call the habitable zone, where we think planets might be habitable in other planetary systems. So on these exoplanetary systems, We want to find other Earths, but we need to understand the search space, that habitable zone space, to know where we should be looking. And I think Venus can help us address this question by helping us better understand what is that boundary? Where does that boundary lie? And what are the processes involved in sustaining or causing a planet to lose habitability over time?
Yeah, and I think I have a couple of things for both of you. But when we're talking about the habitability zones, now our definition of those have changed as we've looked more into the moons of Jupiter and Saturn, kind of. And we look at, my favorite is Europa, but we found that Europa could have liquid water beneath its icy surface, and it could be the gravitational pull between Jupiter and Europa and the sun and different moons going around Jupiter could have created a different kind of habitable zone. So habitable zone no longer means just distance from the sun. It's had different factors. And, that's how everything is, I guess, in space. It's always different factors. There's always different situations where it could be. And that's got to be the same with Venus, where there could have been life there and different things. And before I get to that part, I want to go back. Stephanie, you said it's a kind of a joke of how many times we found water on Mars. And I think I'm interested, have we found liquid water on Mars or simply just ice?
Oh, yeah, we found water ice on Mars and water in the atmosphere, but we have not found liquid water on Mars. That's correct. Yeah, present day Mars is really hard to sustain liquid water just because its atmosphere is so once it hits the surface. But you mentioned Europa, and I mean Enceladus as well, right? These ocean worlds in the outer solar system have no business having liquid water. But it's amazing. It's the interplay of the host planet, right, and the moon and other moons, and how the orbits work to make it possible to sustain these habitable environments way out there, very far from the sun, way outside the what we call the snow line, right, traditionally. So it opens up our just the possibilities for how we can imagine life to potentially take hold beyond Earth and in environments very, very different from Earth. And it just highlights how complicated the question is. It's not just about distance from the sun. It's there are a lot of parameters that you have to consider and understand.
Yeah, it could never be that simple. It can't just be one thing. It can't just be distance from the sun. No, of course not. Yeah, no, that's amazing, and that's why I love. We have so many different. We have so many different. I'm going to call them artists, players in this solar system that are super interesting to look at, and they all give us a different perspective. And I believe it was Voyager that flew through the geyser of Enceladus, or was that? Am I correct on that?
Cassini.
Oh, that's right. Okay, Cassini. Yeah, all right. Cassini flew through the geyser, and that's just amazing to think that we've actually kind of tested that theory a little bit to find. Of course, that helped with the theory, finding if there's liquid water under there. But I do love that. We have our own special ways of figuring out how to get these tiny probes to tell us so much. That's super cool. Now, we've had plenty wonderful things to say about Venus, but now I'm going to turn it around a little bit, and I want to talk a little more about you guys. And one of my favorite questions always to ask is, what is your guys' well, you know what? We'll start with this. We'll start with, how did you guys get into space? What's the journey look like? Like, how did it happen? Was it, at a young age you saw a UFO and that kind of turned you on? You want to figure out where it came from? What was it?
Well, I can start because your mention of Voyager is actually relevant to how I got into space. Because I remember when I was a kid, my mom was describing to me and my sister the Voyagers as they were journeying through the solar system, and how they were taking photographs of the planets, and how they were carrying a golden record on them with sounds and images from Earth. And I was just so taken by that idea of these spacecraft journeying through the solar system, sending data back, but also sending information outward into the stars. I thought that was so amazing. And so I started to get into space. I started to get really excited about space and the planets of our solar system. I checked out all these books from the library in the children's astronomy section about basically every book they had about space science and about our solar system. And it was really amazing to learn about the planets of our solar system and how they were different from Earth and how they were similar in some cases to Earth. So that was how I got into at least my earliest memory of getting into space.
Love it. Oh, that's great.
Great. Yeah, and my story also has to do with a parent. My dad just loved the show Cosmos, the original one, with Carl Sagan, and so we would sit and watch that together. He also he had a telescope that he would take out to dark fields on starry nights and do some photography. He's an amateur photographer, but is amazing. And I just remember being out there in a bonding experience with my dad, taking pictures of a moon on a clear night, or the moon of Earth on a clear night, the field of stars. And so that was I would say the earliest memory that I have of, just really getting excited about the vast array of questions that face space scientists and planetary scientists. And so that was inspiring. I would say that going through college and graduate school, it became very obvious to me that I loved all sciences. So physics was my chosen field, but I just couldn't let go of biology and chemistry. And so that I kind of carried that with me and that curiosity with me. And it turned out that served me really well, getting into where I am in my career now. And so, I've always been just really inspired by the way the natural world can teach us, can kind of work together in the sciences to teach us about profound questions about Earth and our solar system and beyond.
That's awesome too. Gee, Stephanie, can you toss me one of the sciences? I'll take biology. I'll take physics. I'll take one of them. I just want one. Maybe get me into the game a little bit. Sheesh. No, that's great. Yeah, I love all that. Great stories. Mine is also apparent. Both of them. My mother, huge space fan for no reason. I'm pretty sure she's gonna end up getting there somehow. I told her that I'm gonna send her to the moon if it's possible, because she'd like to hang out. But if she could go to Mars and never come back, it would be see ya, and maybe she'd give me some messages from there. And I'd tell her to go for it. She's worked hard. But my dad also, we would go out and we had a nice big telescope and we'd check out Mars and Saturn and Jupiter on some good nights. And so that was always fun as well. Yeah, those wonderful, just simple things of just seeing is believing, making you get interested into it. And that's always great. My next question is one of my favorites I should read more and I've tried to do my best, but I'm getting more into it, of course. But what is your guys' favorite science fiction book? And if you're not into science fiction, what is your favorite book in general? We like to give people recommendations, see what they like to read.
That's cool. Mine is an oldie. It's Brave New World. I read that book I don't know how many times in high school, Aldous Huxley, and I love the examination of like how you overprint the human experience and human nature with kind of a technologically advanced civilization. I found it fascinating.
Thanks.
And my favorite is Contact by Carl Sagan. I like it partly because I think Ellie Arroway, who's the main character in that book, is such an inspiring figure. And I also really enjoy it because I think it was a really fun book to read, but I also have really great memories from college when my friend and I started a club called the Astrobiology Club, and we watched Contact in the planetarium a number of times during club meetings, and those are always really good times. The movie Contact.
Oh, those are great. Yeah, Brave New World is a great one, and I haven't read Contact yet, but maybe I should get into that. Yeah, those are fantastic. And the beautiful thing about science fiction is science fiction can lead to great scientists, but also great just exploration, like mental exploration of what could be, and it can inspire someone like Elon Musk to make his Starship like look like an old 1950s retro futuristic rocket, what they thought it was going to look like. And I love that stuff. That stuff is great. And I think that's a huge part of science. I think it's super influential. It's actually become a question I ask, and I ask people if science fiction is important for space exploration, and it depends on whether or not how you want to look at it for a lot of scientists. But I've also found a lot of scientists don't read science fiction, and they're like, I don't really understand it. Like, I don't get it. But maybe it's because they're living it, and it's not as important for them to feel like they're involved. Yeah. So no, but we're running out of time here. But I wanted to thank you both so much. I'm surrounded by people that are smarter than me. It's fantastic. I am, but it's been great having you guys here. We're hoping that everyone watching this, I know they're going to have a joy listening to it. It's been wonderful. But do you guys have any closing remarks? No pressure.
Yeah, I apologize. I have a lot of background noise because one of my hobbies is to keep my children from killing each other. But also, I'll close out my segment and then go back on mute, I promise. That I really appreciate you having us today, Jim. And I just wanted to mention that we're so excited, not only for the scientific community to go back to Venus, but also, the public, bringing Venus to them, bringing imagery back from human scales. And as we descend over the Tessera region, over Alpha Regio, and we're thinking about ways also on the public engagement side to really bring the public into participating in our mission. So keep an eye out for that, and I'll hand it over to Giada. Thanks again, Jim.
Awesome.
Yeah. We're very, very excited about this mission. We're really excited to be helping lead NASA back to Venus. This is going to collect a wonderful amount of new data. We're hoping to be able to answer so many questions that we've wondered for so long. We want to fill in some of those blanks, but we know that there's going to be new questions that our mission is going to discover. So part of the most exciting part of sending new missions to other planets is the unknown and the unknown questions that we can't yet think to ask. So we're hoping you will all join us on this journey to Venus when we launch later this decade.
Oh yeah, I forgot to mention that 2028, 2029, 2030 is when they're planning to launch. There you go. So everyone, get ready. Buy your tickets now because it's gonna happen. But thank you guys both for coming on. Everybody who's listening, follow us on Space Chams @SpaceChams. Follow us on Instagram @SpaceChams. And you can find this on YouTube, or we're on Spotify and all those other good places. Stay tuned for the DAVINCI missions, and thanks for listening. Always remember to keep looking up.